This is Sunday morning, January the 19th, 2014. We're in Winfield, Kansas, about to do our second series of taxi tests. This test will include the ground station. The first one did not. The airplane is sitting here, the model airplane, in the breeze. It's still kind of windy today. It's probably blowing consistently 10 miles per hour, but gusting a bit. And I think you can see that the airplane, nosed into the wind, is still getting a fair bout of jostling. Unlike our first taxi test, we have all the covers that will be on, including the upper wing skin cover. You can see it is just put on with duct tape. We still want to have access to the servos that are in the wing. Both of the yaw board servos and both of the aileron servos are inside of the wing now. We moved them from underneath the wing at butt line 0 out to where they were more effective and also had less twist and slop, if you will, in them. We have the front hatch off of the airplane right now, and that's so that we still have access to the controls and the camera and other things that we need. You can see that we also have the engine covers on the airplane. We did not have those on our first taxi test. We still have quite a bit of work to do on these to get them the way that we want them, but at least we've got them started. John has power to the system now, and he's getting the telemetry signal. You can see the ailerons and flaps and the yaw boards are all in the neutral position. That's where the controls go to with if the radio joysticks are in neutral, which they are. We now have all the equipment turned on. The telemetry system seems to be working, including the video, even though I can't make a recording of it because there's just too much glare on the screen. John is now replacing the forward hatch, and this is the way the model will look when we get it all together. Obviously there's still more body work to be done on it, and then we have to paint it before we can go fly it. As you can hear, the motor's running and we're moving. John will taxi it up to the other side of Industrial where there is a cul-de-sac, and we will do our testing there. We just crossed Industrial, which you can see here, and we are now in a cul-de-sac where we're going to do our testing for today. We are preparing to do an antenna pattern test where John can check and see if he has total controllability at all aspects around the airplane. To do this, John will set the radio in a low power setting. He'll be about 30 paces, about 100 feet away from the airplane, and he will slowly circle the airplane while he actuates the various control surfaces and the throttle. John's positioning the airplane around the center, about the center of the cul-de-sac, and he's going to point the nose into the wind. Currently the wind is blowing from the southwest. Then he will commence the test. As you can see, the yaw boards are deflected on the right hand side. Only one yaw board deflects at a time. These are not rudders, these are yaw boards, and it is linked to the nose gear until John turns the nose gear actuation switch off, and then it's strictly yaw boards. John is about 100 feet away from the airplane. I am going to rotate the airplane around the CG, I guess, or the wheel, the rear wheels. And when we go to low power on the radio, the engine dies. He, however, still seems to have plenty of control control over the control surfaces. Well, it seemed to pass the antenna pattern test. We don't know why the motor dies when we put it in low power, but John at 100 paces was able, at 30 paces, about 100 feet, was able to continuously control the elevator in the low power situation. Okay, John is going to do some acceleration test up and down the long part, the keyhole of the cul-de-sac, and we'll see how it goes. He is currently down near the cross intersection of Industrial and Central. We're on Central Avenue. We're getting a pretty good blow around out here. We have some potential traffic coming. There it goes. He's turning, although he is watching.
Makes it kind of squirrely.
Yep. I know, let's don't do anything too risky. The wind is gusting. It's real light right now, but as it passed by here just a moment ago, it did blow it a little bit. It did have a gust. We have very large balloon tires on this airplane. It's trying to keep it to scale, which means I need 6-inch diameter tires, and the only ones I could find are balloon tires for, I assume, off-field landing type models that are pretty large, and unfortunately that causes a lot of bouncing. This is the ground station hardware, most of it provided by Eagle Tree. You can see there's not a lot to it. And then we have two computers, one of which provides real-time telemetry data for the instrumentation, and the other computer is the HUD. John's setting up the software. There's a sequence that we have to use to get this thing working. John has become a master of it. Unfortunately, I don't think we're going to be able to see the screens, which I was hoping we'd be able to do today as we collect data. Are you going? This is the data that was recorded real time from the FDR, the Eagle Tree FDR, from our little taxi test this morning. Again, it's still January the 19th, 2014. You can see that we have a number of different instruments displayed here. Some are displayed as dials. The one on the left is, John, I can't read it.
Altitude.
Altitude. The next one is, I believe, speed. The third one from the left is the angle of attack sensor. And then the fourth one from the left is the beta or yaw sensor. And that one is not installed right now. That's why it has such a fine gradient. You can see that we're collecting data. There's a timer at the top. You can see John pointing out different changes of the aileron positions. Actually, we haven't even started moving the airplane yet. I'm going to turn this off until we get to something a little more interesting. The four sensors which show control surface position, John, would you point those out? Those have different values. That is their neutral point, but basically this is showing when they're deflected. If you'll look at the two center ones, the ones there and there, those are the currents that are through two of the four sensors. The other two currents are on a different logger, an e-logger, as opposed to the flight data recorder, and we have to download those after the flight. The right-hand side, we'll get up close to it, is the RPM, and we don't have the RPM meter set up yet, or the tachometer. The second is the head temperature, and that seems to be running pretty high, so I'm a little concerned. I don't think it's really real. And then the bottom one is the battery temperature. Battery voltage. You can see that the altitude is showing about 600 or 700 feet, which that's not correct. Obviously we're at about 1,200 feet here. The beta sensor, the alpha sensor, you can see that it's moving around. Now, unfortunately, we can't go in and calibrate or change out the scale on this, so we have to find zero and then just know where it is and look at plus and minus whatever the maximum deflection is up and down. So you can see that we're still getting some changes, both in the currents and in the positions of the various control surfaces. We're monitoring one aileron, one yaw board, one flap, and one elevator. We do not have both sides of each of those being monitored, just one. That's all the channels that we had available on this. This is the e-logger data, and it has to be downloaded when we land. It is not real-time data. And you can see again it has a timer. These time scales, if you will, or timelines, are different from the FDR because we didn't clear out both of these. In other words, they already had some time on them before we started. John, we have on this a G-force on the x-axis, G-force on the y-axis, G-force on the z-axis,
flap current, and yaw current. So we're trying to run the flaps and the yaw boards off of this. We're going to swap that around, I think. Anyway, that's the data that we get on this, and you can see the timer that's associated with it. We hope to be able to sync both of these. Well, actually, if we clear them out, both of the FDR and the E-logger, when we turn the system on, they will start at exactly the same time, so we will have a synchronization between these two sets of data. We're back looking at the FDR data, and if you look, the alpha sensor is getting flicked all over the place because it's been real breezy out there, and obviously we weren't going very fast when we were recording this. And you will see occasionally a speed change on this. It's gone up as much as 20 miles an hour, but you have to be right there with it. You have to be recording it at the time.